Hello, I'm Tomasz Tarczyński. I'm a system architect at Gigaset, and I want to talk today about cloud native. So, what does it really mean? And is it something that we all should care about? There was a great previous talk here where Martin gave us a very brief intro to cloud native, and I would like to go into some more detail of what it is. But let me start with asking you a question. So, by a show of hands, how many of you have heard more and more about cloud native in the recent year or two? Okay, thank you. And how many of you have a clear definition or understanding of what it is really about? Okay, thank you. So I think this talk might be on point. For me personally, I've heard a lot about it in the last 3 years, but it wasn't clear to me at all what's the essence of it. But let me first start with a short story to explain why am I interested in this topic. So at Gigaset, we work on a smart home system, which lets our customers to monitor the safety of their homes and also to program some automated actions. And this system is built from 3 main parts. So there are the devices, the sensors like the door sensor, motion sensor, actors like a smart plug, things like smart camera. Then on the other end of the system are our customers. They've got applications on smartphones, and those lets them be notified about events at home, to check the history of those events, and also to program some actions. But for those 2 parts to work together, we need something third in between. So there is the brains of the whole system. In this backend part that lives in the cloud, actually all the logic of the system is deployed here. So any kind of functionality that we do is done with code deployed here. And as we want to make our customers happy with our system, we need to ensure 2 important non-functional requirements. And those are, first, about reliability. We need the system to be super reliable, to limit any malfunction or unavailability to a minimum. Also, to make sure that response times are ultra fast. It's because basically all the functions that we have are not worth much if the system happens to be unavailable, and also if a customer waits for a few seconds in the smartphone app to respond, it's a very bad user experience. Then the second requirement here, it's about velocity. So how fast can we deliver new features to our customers? It means to us that we don't want to go through something like a month-long process while working on some new feature, but actually to be able to do something like going from code being committed to version control by developer to it running on production, to go this path in something like an hour or 2. So those are the 2 requirements that we have. And to achieve those 2, we were working constantly on improving our technology and our practices. And I would like to tell you just about a few important changes that we've made to this platform. First of those was about how we package and run our applications. So before the migration that we did, it was that all applications were packaged in RPM packages, and then it were running on servers with some process supervisor like systemd. We moved from that to Docker containers, to have a standard packaging format, to have those containers taking care of, so to take care about dependencies, to have this immutable artifact deployed on our environments. And yeah, speaking of dependencies, to no longer go through dependency hell, like making sure that the environment in which the application runs is always the same, no matter is it in development or in production. Working this way, this is much easier to build, run, and to manage our applications. Second change that we made is about the architecture of the platform. We've started some years ago with a monolith, and what we did then, we migrated from this monolith where all the functionality of our backend was done in one application to a microservices architecture. So each function of our system is now done within a small dedicated application. This way, they are much easier to develop and to deploy, basically because they are much decoupled one from another. So basically a developer working on one application no longer needs to synchronize with other developers to be able to deploy their work. So it also makes the work much faster and delivering features much faster. What's important for such developer, as it's decoupled, they only need to make sure that changes that they make are backward compatible. So they keep the contract that the API still works. And the third change that we were going through is about automation. So how we deliver changes to infrastructure. So it used to be, some parts of it used to be manual, and now we moved to fully automated. So all the changes defined with the code that is stored in version control. So we've got a clear view on the history of all the changes, and it's much easier for us to, for example, roll back something if a change goes wrong. It allows us to actually take more risk, because if we've got the safety that each change could be very easily rolled back, so then it's not a problem to experiment, and if something goes wrong, to just take a step back. But going down this path, doing this migration, we've also seen some challenges. In our case, the challenge was about the growing number of applications. It started to be bigger and bigger a trouble for us to manage those, even with all the automation that we got. So we used Puppet as our automation tool of choice to keep this all running. And the tool was great at its job, which is configuration management of all the nodes in our infrastructure. But when the number of application instances in the environment went near 300, we've seen, or we felt that we are actually hitting the limits of that approach, that it actually is limiting how fast can we move, how fast can we deploy things. What we wanted to do is that we wanted to be able to focus on the application, to focus how it should run, what configuration should it get, what resources does it require. But working with traditional configuration management, like Puppet, we've seen that this tool was very much host-centric. So we had to describe how each host should be configured. We needed to focus on many operating system level details. So manage what things to install on each system, what configuration files should be there, and what services should run. So we were looking for something else, for something that would be a better fit for such a task. Our idea was that we need something to orchestrate those microservices and to do it dynamically for us on a big cluster of machines. So to be able to not worry so much about the state of individual nodes, but rather to be able to manage the state of the whole cluster. So to learn about what are the possible solutions to this, I went to a cloud native conference, and there I've seen this cloud native landscape with tons of useful technologies. I've learned about some great tools that can help us to manage our microservices dynamically. But what I didn't learn there was what this cloud native is really about. So then I started to dig into how different people describe and explain it. And I found several different definitions, different points of view about that. And actually that those definitions are also still evolving. So there are different opinions there, and it changes. But the first question to answer for me was, why should I actually care about this? So what benefits can we get from this approach? And if it's any good, also how can I sell it to my boss? So how can I convince someone who decides what we use? So there are a number of case studies available from the companies that adopted cloud native approach already. Among them are the Financial Times, Zalando, and of course there are unicorns like Netflix who have used similar methods for years. And let's take a look just in one such case study. It's available via Container Solutions. In their small book on cloud native, they gave an example from Financial Times, which is a news organization read by more than 2 million people daily. And what's interesting, they earn more from their digital version than from print. So at Financial Times, they've spent 3 years building a cloud native platform and then migrating applications to it. And what results did they get? So I've put here just 3 metrics that are very important to business people. So what our business usually care about. First metric here is about reliability. Basically, before that migration, Financial Times needed to roll back 1 deployment in 5. And after they migrated to cloud native, it's only 1 in 1,000. So a great improvement for them. Okay, the next metric is about velocity, how fast can they go. So what lead time means. It's the time needed to go from code being committed to version control to it being running on production. It used to be 4 months for them. So such a process to deliver change. And after they migrated, it's only 15 minutes. So change 4,000 times. And the last one, again about speed. How often can they deploy to production? Used to be 12 releases a year, and now it's 2,000. So I would think this kinds of metrics is something that would quite easily convince business to invest in such a change in an organization. If you are interested in this kind of case studies and to see how different companies dealt with that, I would recommend to you a talk. It's by Sarah Wells from Financial Times. The talk was done in KubeCon 2018. And what is interesting to me in that talk is that she mentioned that not only they've seen all those improvements in reliability and velocity, but also the operational costs went down by something like 80%. So they were using their compute infrastructure much more efficiently. And now just one more example. So from Gigaset, and just to shortly show you what benefits we've seen after migrating to microservices. About reliability, we also had quite a lot of failures related to change, but it improved a lot. Then another interesting metric to me is MTTR, so it's mean time to recovery. It means if something goes wrong on our production environment, how much time do we need to restore it to a working good state? With the old platform, it used to be on average 8 hours for us, so a big struggle to restore services. And with microservices, only 15 minutes. And the last one about speed, how often can we deploy? It also improved for us more than 200 times. So even in a technology organization like ours, it also shows good benefits. If you are interested in those kinds of metrics to see how different companies are performing, I really recommend the State of DevOps report from 2018, the newest one. It's a study based on 5 years of surveying. They've got about 30,000 responses from technical professionals worldwide. And what they do is they compare different organizations in how they perform regarding to software delivery. They split them into different groups, clusters like low performance, high performance, and then they also try to identify from those surveys what practices led those organizations to be high performing. So what is correlated to high performance? And just 2 highlights from there. One of such practices was using of cloud computing with the 5 essential characteristics being met. You can go into this report to check this in more detail, but basically it means it's not enough to just be using AWS, but actually to provide all those capabilities to our technical teams. And another highlight from them was about cloud native, that this kind of architecture is also correlated with high performance in organizations. Okay, so wrapping this up, those case studies, what are the benefits from cloud native? It's, as Martin said in previous talk, all about speed probably, but we also have a big benefit in reliability. Actually, by splitting our applications in small components, we can ensure that any failure that happens in our product is actually limited to some small part of functionality. So scope of such failures is much smaller. Maybe it could even be not noticed by our customers. And also, what's good, we can have an autonomous system managing our applications and infrastructure. So it means that it can react to failures of individual components and do that without human intervention required. So this would be the first big win. Another, of course, velocity. So companies using cloud native can increase the velocity, so deliver features to customers much faster, and it's by using the self-service platform. So they use it to deploy small increments of work, and it can be done by developers, by technical teams, by their own. And just one interesting graphic taken from actually a presentation by Netflix. It's how Netflix sees the relation between those two aspects. So we've got availability and the rate of change. And what they shown some years ago was that there is this relation that actually if we want to have higher availability, typically we would need to slow down the changes on the environment. And the other way around, if we actually want to go faster, to deliver changes faster, then our availability would probably go down. And what they explained back then was that actually, if we want to shift this curve up and to be able to improve both availability and rate of change, we actually need radical changes in our architecture, in technology, and practices. So it's a lot of things that we need to rethink. And of course, Netflix did that years ago, and as we know, they've got great results from that. And going back to those benefits, the third one is about efficiency. And for me, it means actually how much work do we need to put into management of our infrastructure. With cloud native, it's much less of that work. Much less things needs to be taken care by humans. And this autonomous systems are much better and much more efficient in that. It's basically because now all the routine decisions can be made by a platform. And another thing here is that also infrastructure costs can go down. And it's because of much better utilization of our hardware resources. Okay, the next question to answer for me was, how can I implement this cloud-native approach to building and running applications? And among the different methods that are mentioned there, there are the three that are actually most often advised. And those are as follows. First is to package your applications into containers and use them as a unit of application deployment. They give you a lightweight isolation of applications and also a standard control interface for each application. It gives also a great benefit of standardization. So it lets you to standardize on a single package format, one way to deploy, and one way to control the application. And what's also, so it was said by guys from Google about containers, why do they use them? It's basically because containers let them transform the data center from being machine-oriented to be application-oriented. So you want to no longer force engineers to worry about the machines. Second method is that you have your applications dynamically managed by an autonomous orchestrator. So then a human needs only to describe the desired state of the whole cluster and not deal with individual machines. And then the application lifecycle is taken care of by software. So working this way, a developer can get a self-service logical infrastructure. This kind of approach eliminates a lot of the hard work done by operations typically. So it's no longer so much needed to go to your ops guy and ask them to make changes to the infrastructure, but you can just define what should work on this cluster. And then actually computers decide which workload goes where on your cluster. So you've got this central piece, an orchestrator that makes that decisions. And also, it applies fixes when a piece of hardware fails. So you've got this infrastructure that is automatically healing itself. And the third method is about microservices architecture. So you break down your applications to microservices that are small, single purpose, and decoupled, with well-defined interfaces between them. For example, like a REST API. You then benefit from them being easier to develop and update, and also cheaper to operate. Each such microservice can be owned by a small team. That team can deploy it at will, independently from other teams, and they can also scale it up or down independently. Okay, so then cloud native, it seems to be a technological paradigm that prescribes basically those three methods: container packaged applications, dynamically managed, and microservices architecture. And one more theme that is, I think, also related to that. So how do you want to architect your applications to be able to run in such an environment? And there is this very interesting methodology from Heroku called 12-factor apps, and it prescribes some key characteristics that your application should match to run well in such an environment. I would just highlight a few of those, not go through all of them. But the second one here about dependencies. So it's that your application should never rely on a system-wide packages. So it should not assume that something is installed on the OS level, but rather should have those dependencies packaged within the application and deployed together, and should be the same whatever environment you go to. The third characteristic about configuration, so they say that it's best to actually deliver configuration in environment variables, and also that this configuration should be the only thing that's different between different deploys of your applications. So the artifact is always the same, the dependency is the same, and only configuration differs. And then scaling out with process model. What it means, the processes should be stateless. So we should not have any shared state between one and another request coming to our application. And this way, we should allow to distribute those requests in a round-robin fashion to many instances, probably running on different hosts. And the other half, other portion of those advices, this one here about port binding, so how the functionality of your application should be exposed. What they advise is to do this always by port binding, so basically to respond on request via network and not other means of exposing functionality should be allowed, so no things like shared storage and that kind of communication. Then concurrency. So it's again like you've got multiple instances of the process running on multiple machines, and they should share nothing with them, between them. And the last one that I would mention, disposability. So for those applications to be robust, to really work well on such dynamic environment, you need to make sure that they can be started and stopped really, really fast. And that's for elastic scaling and rapid deployment of those, also reacting to failures. So the startup procedure should be ideally something that could happen in just a few seconds. And also applications should be able to gracefully shut down on receiving a signal from orchestrator. Okay, so going back to the definition of cloud native, when I've tried to find how people define cloud native, I most liked what Justin Garrison and Chris Nova said in their book Cloud Native Infrastructure, which I really recommend. They said that it's about the infrastructure that is hidden behind useful abstractions. So you no longer deal with individual machines, but you have an API to control the whole cluster. Then this infrastructure is managed by software. So there is an autonomous orchestrator which constantly makes sure that the cluster is in the desired state. And also, applications are designed to be managed by software, not by humans. You can think about this 12-factor apps manifesto I've just mentioned. So then, instead of producing operational documentation or writing sophisticated scripts to automate them, we rather make sure that we have standardized app interfaces and that they could be taken care of by our autonomous orchestrator there. Okay, but as we are on the DevOps Days conference today, I wanted also to look into how does it relate, this cloud native, to DevOps. So if we've got this new bright thing there, cloud native, should we actually forget about anything DevOps that we learned so far? So let's take a look what people say about DevOps and how different people see the area of interest of DevOps. So one definition that I really like is by Adam Jacob from his DevOps Kung Fu presentation. That's also really something really fun and interesting. But he basically says that DevOps is a cultural and professional movement, and it focuses mostly on high velocity. So yeah, this high velocity part would be something really in common between DevOps and cloud native. And then another view on DevOps as a thing, it's done by John Willis about 8 years ago or so. He defined the areas of interest, what DevOps practitioners try to improve. And there are 4 of those. So culture, automation, measurement, and sharing. And we speak about those topics quite a lot on DevOps Days conferences. And if you compare this list with what I've said about cloud native, you can think about it that our technological paradigm and all those projects, technologies in the cloud native landscape, they goes mainly into those 2 parts of DevOps interests. So they're focused on either automation topics or measurements. But what I would also argue is that actually to be able to use all those cloud native methods and run such a platform, you still need to care a lot about the other DevOps areas like culture and sharing. That basically doing cloud native kind of platform is not possible without all those. And just being near to end of my presentation, just one more thing. How do you think? Is all that I've talked about, is it something very new? Do you think it is something possible just for the last 2 years or so? So what I'm going to show you just a bit of history. So what different companies were doing. So first area, so containers. It's actually, in speaking about Linux, it was started at Google in 2006 when they started work on C groups. Then it was generally available to wider public in Linux kernel mainline in 2008, and also the userland tooling started in that year with Linux containers. And just some 5 years later, Docker started with their first release. Second area, about orchestration. Here it's Google again, but in some mid-2000s, they were already working with a cluster orchestrator that they call Borg, which let them work actually this way that we are talking about today with Kubernetes and all those orchestrators. But not only this one, also in 2009, the Mesos project started. Another example of an orchestrator taking this idea of dynamic management of the whole cluster. Actually, it was also inspired by the Google work on Borg, by some people who used to work at Google who inspired that project. Then 2010, Twitter started using Mesos, and 2014, we've got first Kubernetes release. And the third area about cloud and microservices. So what kind of architectures are we building? So AWS is something that started 2006 with S3 at EC2. At the same, in the same year, we've got Amazon's CTO, Werner Vogels, who talked about how they organize microservices internally, how they have self-service teams, and there was this famous quotation from him, like, you built it, you run it. Means a single team owns a service and have all the capabilities to run it. 2010, Amazon moves all of its retail to AWS. So they were all on their own cloud. And the same year, Netflix moved to AWS and also started their open source projects. So making all of their cloud-related technology available to a wider public and letting us use those. And next year, 12-factor manifesto was first announced by Heroku. So what I would say is actually those ideas are not new at all. We've got those things possible for the last decade or so, but what had actually changed is now all those cloud-native methods are much democratized. Actually, we have those great open source projects that allow even small technical teams to get the same robust technology that was earlier available only to those biggest unicorns like Google or Amazon. And what's also great, we've got this cloud-native computing foundation today, which we can go to and use as a guide to this huge number of technologies to be able to say which technology can we depend on, how mature those are. Okay, so that's all that I have for you today. I'm Tomasz Tarczyński, and thank you very much for listening.
Thank you, Tomasz. I think we have time for 2 questions.
Okay, so the first question, thanks. I mean, people could argue that serverless is the next step. I was wondering why you didn't mention on your presentation.
So the question was about serverless, and I would think about serverless as it is actually a part of those ideas, this movement through cloud native. Basically, I would think to actually be able, by using serverless, you've got pretty much the very same benefits, and actually your platform would look very similar, but the difference could be on what level you operate. Probably running serverless from some service provider, you don't care even about the cluster operator, but it's similar.
One more question? Okay, here we have one.
Hi, you didn't mention about it directly in your presentation, so I was wondering how many guys have been fired after you migrated to cloud native in Gigaset?
How many guys have been fired? Okay, yeah, that's a good question, but no one actually. What we've seen was that actually we were able to deliver orders of magnitude more functionalities. So the win was on how much can we do, not on how much cost can we cut on our stuff. Uh-huh. Yep. Yes, yeah, basically the team size is the same, but amount of work done by this not so big a team, it's way bigger. So that's the difference that we see.
So in the end, no one was fired, right?
No one, yeah.
Okay, thank you, Tomasz.
Thank you.